and welcome back to Physics Chat. This is the show where we talk to a variety of physicists about their research and learn more about what it's like to be a modern day physicist. I'm Susanna and I'm back with my lovely co-hosts Joe and Sergi, ready to do some more chatting. Today we are here with the extremely hilarious Simone. Hello Simone, how are you doing?
Hi Susanna, thank you very much. I'm doing very good, thank you. I'm very excited to be here.
Well, thank you for being on the show. And Simone is a final year PhD student at the University of Portsmouth researching gravitational waves. I have the huge privilege of working with him as we are both part of the same gravitational wave research group. Simone, you know me, I enjoy talking and we can chat about anything from gravitational waves to food. So tell me, if you were a pizza topping, what would you be and why? This is part of the show where I just ask a random question.
Oh, that's a very good question. So in my region is very famous for a particular kind of ham that is called San Daniele ham, or prosciutto di San Daniele in Italian. And so I would definitely put that in my pizza. And I think that I will put mushrooms as well. So I will have mushroom and ham pizza.
Amazing. What about you, Sergi? If you were a pizza topping, what would you be and why?
Well, it's a difficult question. I think that the best pizza is the margarita, so no toppings. But if I had to choose one, I would say mushrooms as well.
Mushrooms, nice. And what about you, Joe? What would you be if you were a pizza topping?
I think I'd have to go. I would be the cheese. I'm basic, I'm needed, and I've got some variety, but not too much.
Oh, nice.
What cheese would you add, Joe?
Oh no, this is a tough one. When I've made pizzas, I've used mozzarella, but that's as far as I've done.
Nice.
Good answer.
It's dangerous.
I think for me, I'd be pineapple because I couldn't care less
No.
what people
Why?
Awful.
or not.
We can stop the recording, please.
I knew it.
Brilliant. Oh, well, thank you, Simone, for again being on the show. And could you describe in one sentence what you are researching at the moment?
Yeah, well, our collaboration is going to stop after this revelation of the pineapple over pizza. But okay, let's try to move on. So as Susanna said, I'm part of the gravitational wave group. And so what I do is try to mitigate the impact of noise transients in the analysis of gravitational wave data. Oh,
wow. That sounds really cool. So could you explain more about what gravitational wave actually is?
Yes, absolutely. So gravitational waves are tiny ripples in space-time that are generated by accelerating mass in the universe. So all of us, me, you, Susanna, Joe, and Sergi, we all generate gravitational waves because we are all accelerating with the Earth around the solar system. And what happened is that this effect is so small that to be visible, we need very massive object. So for seeing something like our gravitational wave, we need a super sensible detector that we don't have at the moment. So we are just trying to focus at the moment on the detection of binary black holes and binary neutron stars that are one of the most massive compact objects that you can see in the universe.
Wow.
So, Simone, your research that you were talking about, what specifically is it that you do and why is it so important?
Well, essentially, you have to imagine that given that these signals are so small, we need to have an incredible sensitive detector to detect them. And whenever source of noise will just makes it harder to see this signal. So imagine to be in a very, very busy street in London, and you're trying to listen to your favorite song with your 2-pound headphones, right? And yeah, unfortunately, there are people chatting, there are cars on the street, so you basically don't hear absolutely anything. So it would be great to have all these noises just removed. So you say, okay, let's go to an amazing supermarket and buy the state-of-the-art of noise-canceling headphones and try to wear them. Now things are doing much better. But given that the signals is still so low, so our music, the volume of our song is very, very low, is still very hard to listen to them. So what we need to do is to try to make the song as loud as possible, trying to remove all the residual noise and try to model the noise.
Okay, so what kind of things are causing the noise to wash out the gravitational wave signals?
Well, there are all different sorts of noise. I mean, I've been on one of beam detectors, and at some point I was able to see myself walking along the detector. So really everything that you can imagine. But there was one very fun fact that was during one of the first observing run, we were seeing a very well modulated signal, and that was a transient in our data that was appearing at the same particular time during the day. And so we were trying to understand what it was. We were thinking of, maybe it's a super incredible astrophysical signal that we didn't expect, right? But at the end, we realized that it was a crow that was pecking on the tube of the detector. And because it was trying to get the water out of the ice in a compressor in the detector. So, I mean, what we could have been one of the greatest discovery in of our time was just at the end a bird, but it's fine.
Wow, amazing that something so small can keep physicists stumped for so long.
Yeah.
So what recently has been, would you say, the biggest breakthrough in your field as well?
Well, gravitational wave is a very new topic in physics. So the first discovery of gravitational wave, with the first detection of gravitational waves was in 2015. And we saw for the first time the merging of two black holes. And so this was an incredible breakthrough, and opens for the first time the sky to a complete. I mean, our sky to a completely new probe that is gravitational wave that is completely different from light. But I think that one of the most exciting discovery has been the detection of binary neutron stars, because in that case, from the theoretical model, we know that there is emission of gravitational waves and also emission of light. So we were actually able to see both of them in 2017. And so I think that this was the most exciting thing that we had recently in gravitational waves.
Fantastic, thank you.
Yeah, I agree with you, Simone. I think that detection was amazing, and I've actually come up with that thing in my research as well. So it has spread in different areas. But I wanted to ask you about something which has nothing to do with gravitational waves, because you've been taking part in a project which has nothing to do with gravitational waves, at least from the surface, and it's about ivory, which is this material of the horns of the elephants. So can you tell us a bit more about what is this project? What issue is it trying to solve?
First of all, I decided to change the topic of my research for a while, and in particular for 3 months, because the PhD is an amazing experience, but can be very exhausting after 3 years of putting all of your passion in this on these topics. Sometimes you just need a break. So I took the opportunity of doing a placement with the University of Portsmouth. And the placement is about try to help the law enforcement officer to stop the illegal trading of ivory in online marketplaces. The main problem is that on online marketplaces, there are a lot of things that resembles ivory that are sold legally. For example, bones, for example, horns, or even plastic that is very similar to ivory, that is called ivory. So it's very hard for officers to just distinguish between the different adverts just for the volume of the adverts that there is online, right? What we are really trying to do is to create an automatic program that automatically distinguish bones from ivory, from horn. So everything that resembles ivory, we want something that automatically separate all the images. So as you can see from this picture, this was me at the very beginning of my project. As you can see here in the picture, I have 3 different objects, and all of them seems made of the same material, but they're actually 3 different things. One of them is ivory, that is a particular kind of plastic that resembles ivory. One of them is horn, and one other is actually ivory. So, I mean, as you can see, I was very confused at the beginning, just because it's very hard to resemble them. And you have to imagine that it's exactly the same for the police officer. To be able to distinguish between them need a lot of training. What we tried to do was to develop a program to automatically distinguish between ivory and bones, so that my program would have directly tells the police officers, yeah, let's just focus on these things that we are pretty confident that they are ivory, right? And this would just reduce the volume of information that officers has to analyze.
And I think it would be interesting for people to know, how is it that someone like you, who is specialized in gravitational waves, can actually take part in such a different topic and be able to have the amazing results that you have?
Yeah, that's a very interesting question. So during my research, I basically analyze data, and I analyze time series. So to be able to analyze time series, I had to develop a whole range of skills that are very typical of the data scientist. And this helped me when moving to another project. And this, in particular now, on the Ivory project, I was analyzing images. So I used some of the skills that I developed during my research as a data scientist to analyze images of ivory.
That's amazing. Thank you, Simone.
Yeah, thank you so much. That is so fascinating to see how actually physicists are helping to protect endangered species and in the conservation effort. Thank you so much for telling us about that. So again, Simone, thank you again for being on the show. We really enjoyed chatting with you today, and we wish you all the best in the future.
Thank you very much, all of you, for inviting me here. It's been nice chatting with you.
We hope you will join us again sometime soon, as we're going to be interviewing some really cool people in the next few weeks. So be ready to join Sergi, Joe, and myself for another physics chat. In the meantime, please let us know in the comments your answer to my random question. If you were a pizza topping, what would you be and why? We would honestly love to hear your responses, so keep writing and we hope to see them. Anyway, in the meantime, we all hope you have a great day and see you soon. Bye.
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 Bye. Can we please mute Susanna?